we are going to add one more thing to solving equations. This is the last thing we have to add. We're going to put, if you look at these equations, there is a variable on both sides of the equal sign. So there's one more thing we've got to look at. We're going to do a couple of examples together. Today they're going to be very simple. Tomorrow we'll make them a little more complicated. Okay? Let's write our steps down. As I write over here, I want you to write your steps so that you have something to follow. So our first step, first thing you want to do is find the equal sign. That's important. Okay, the equal sign makes all the difference. We're going to put our little line through it to help us. We know we have a left side and a right side, correct? Now, after you do that, the next thing you're going to look for is if you have to distribute. You're going to check the left side. You're going to check the right side. So I look at this particular equation. Is there any distributive on the left side? No, I'm good. Is there any distributive property on the right side? No, I'm good. So I can skip this step this time. Woohoo! All right, after we distribute, what do we look for next? Can we combine anything? Now, here's where we're going to tend to make the mistakes. In order to combine like terms, they have to be on the same side of the equal sign. So we're just going to check the left side and the right side. Okay? So when I look at the left side here, can I combine anything on the left? No, those are not like terms. Can I combine anything on the right? No, those are not like terms. Now what you're going to want to do, you're going to want to say 7n and 10n. But if that equal sign's between them, you cannot circle to combine. The equal sign's a barrier. Since these are on different sides of the equal sign, they cannot be combined. You can only combine things that are on the same side of the equal sign. Now, after you've checked for distributive property, after you've checked if you can combine anything on either side, not between the sides, here's the new move. The new move is to move the smallest variable from one side to the other. Okay, so I've noticed I have a 7n on the left, a 10n on the right. I cannot combine them. I have to move one of them. Which one's smaller, 7n or 10n? Well, 7's smaller, right? So I need to move this positive 7n. How do I move a positive 7n from one side to the other? Well, you subtract it, just like you do with numbers. We've not done this with variables before, just numbers. Now we're doing it with variables. Whatever you do to one side, you have to do to the other. Remember, when you go underneath like this, that equal sign's got to be in between them. So look what happens. 7n minus 7n, gone. I'm going to bring down a, what kind of 5? A minus 5. Don't forget those minus signs in the middle. Bring down your equal sign. Now, look at this. 10n minus 7n. What is 10n minus 7n? 10n minus 7n is 3n. Bring down the plus 13. Now, all of a sudden, I have a two-step equation. So the last step is to solve the two-step equation. We can do these with our eyes closed, right? We've been doing them for weeks now. So I find my variable. My variable's here. I've got a plus 13. I'm going to subtract 13 from both sides. I'm going to run out of room, aren't I? Here I've got a minus 5 and a minus 13. That's minus 18 equals 3n. That's cancels. I'm going to divide both sides by 3, and I get n is negative 6. So this right here, that's the new part. Okay, let's try it again with this next one. 5n minus 2 equals 3n plus 6. Our first step, find the equal sign. My equal sign's there. I'm going to draw a line so that I can tell my left side from my right side. Next thing I want to check, anything to distribute on the left. Distributive property on the left? No. Distributive property on the right? No. The next step, are there any like terms to combine on the left and on the right? Any like terms on the left? No. Any like terms on the right? No. So once there's nothing to distribute and nothing to combine, then I'm ready for the next step. Move the smallest variable from one side to the other. So I look at my variables. I have a 5n, I have a 3n. What's smaller, 5 or 3? 3n. So I've got a positive 3n. How am I going to move a positive 3n? I'm going to subtract it. Whatever I do to one side, I have to do to the other. So I have 5n minus 3n. That's 2n. Bring down the minus 2 equals, those became 0. They're gone. 6. All of a sudden, two-step equation, no problem. So let's finish this one up. I'm going to add 2 to both sides. 2n equals 8. Divide both sides by 2, and n is 4. I'm going to suggest right here, as you look at these two problems are very similar to what we just did. I'm going to suggest that you pause the video, stop it, you try to work these two problems using the example we just did, or the two examples we just did, then turn the video back on. I'll have them work and see how you did. And if you have any questions on how any of it worked, just raise your hand and I'll come help you. So pause the video, try this next one on your own. I got y equals 7. Is that what you got? I found my equal sign. There was nothing to distribute on either side. There was nothing to combine on either side. I found my smallest variable, 8y. I subtracted 8y from both sides. I brought down my 4. 11y minus 8y is 3y. Brought down my minus 17. Then I had a two-step equation. I got y equals 7. Okay? Pause the video. Try this next one. Pay attention to this m. Remember what's in front of it. Did you get negative 2? I looked on the left. There was nothing to distribute or combine. I looked on the right. There was nothing to distribute or combine. 1m is smaller than 9m, so I subtracted 1m from both sides. I remembered there's a minus here. I brought down minus 1. 9m minus 1m is 8m. I brought down the 15. Two-step equation, did a little bit of sign work. I got m is negative 2. Sometimes when we put a variable on both sides of the equal sign, we end up with some weird stuff going on. Okay? So let's look at that now. First of all, what do we do first? We find our equal sign. Then, what's the next thing we look for? We look for the distributive property. Is there anything to distribute on the left? There is. So I'm going to distribute my 5. 5 times 2x is 10x. 5 times 1 is 5. Equals 10x. Nothing to distribute on the left. Is there anything to combine on the left? Nope, not like terms. Anything to combine on the right? Nope, it's all over there by itself. So I'm going to move the smallest variable. Well, 10x and 10x are the same thing, right? But I still got to move one. So how do I move a positive 10x? I subtract it. I'm going to subtract 10x from both sides. 10x minus 10x is 0, goes away. I'm left with a 5. Equals 10x minus 10x is what? 0. Is there anything else over there? No. So I get this statement, 5 equals 0. How strange. Well, what you ask yourself is how often does 5 equal 0? Never. And if you get something that can't possibly be true ever, your answer is no solution. Here's why. Look right here at this step. 10x plus 5 equals 10x. Well, is there any way I can multiply a number by 10, add 5 to it, and it be the same as if I didn't add anything to it? Is this possible right here, that 10x and 10x plus 5 would ever be the same thing? No. So this means there is no value of x that makes this true. Not possible to get an answer, so you write no solution. Now, let's look at the second special case. Find your equal sign. Look at your left. Any distributive property on the left? Nope. Any distributive property on the right? Yes. 2 times 3x is 6x. 2 times 1 is 2. So I'm going to bring this over here. Something's looking a little strange already, but let's keep going. Can I combine anything on the left? Nope. Can I combine anything on the right? Now I need to move a variable. Well, they're the same again, so I pick one. It's a positive 6x, so I'm going to subtract 6x from both sides. That goes away, and I'm left with 2 equals, that goes away, and I'm left with 2. How often does 2 equal 2? Always. If you get something that's always true, that means there's a lot of answers, okay? So you look up here, right up here, how often is 6x plus 2 equal to 6x plus 2? Always. Does it matter what I plug in for x? I could plug in 1, 2, 500, or negative 3/10, and this would always be a true statement. So if you get something that's always a true statement, you can answer this a couple of ways. You might see the answer many solutions, meaning there's a bunch of things I could plug in for x and it work. Or you might see the fancier sounding infinitely many solutions. So sometimes you're just going to get an answer, but sometimes if you get something that can't be true, that means there's not an answer. And if you get something that's always true, there are many solutions, or infinitely many solutions. Okay? Those are your two special cases. Now you're ready to do some practice.